Okay, so we were here and I was saying that I was actually explaining how we can import a file into another file that is in Rust. Now, that is basically what I did. Now, to call the function, to call this function, what I simply need to do is do the print. Now, in this case, what I just brought in, and this is how I call that particular method using the double colon, full colon in that case, and calling that particular function. Now, it doesn't require any parameters, so I'll just go ahead and let's go ahead and do cargo run and see if this is going to actually run. Awesome. So that was that went successfully, and we had in our terminal a string printed out. Now, that is basically how you could print a string, but then there could be a point where you want to print a string, but then format it in some sort of ways, right? And again, this function I'm using to print is a macro. We refer to it as a macro in Rust. So I'm going to share with us a book or a link where you can read more about Rust programming language, and you're going to, that will help you know what a macro is in Rust. So basically, it's just like a decorator in TypeScript. So if you're coming from a JavaScript background, it's like a decorator. So it's sort of a code that is already existing, so you can just use it within your program to make work easier. Now, in this case, we're going to print, assuming we wanted to print hello, but then we wanted this to be followed by a name, right? So in this case, we could have a variable right here. And again, I'll be talking about variable definition or more about variables in the future. So for now, let's just do this. For now, let's just do this. Then right here, I'm going to, okay, first of all, you're going to use that type of formatting. So you basically use these curly brackets, the double curly brackets. So these double curly brackets are basically placeholders for whatever we're going to put after this particular comma in our statement. So in the first position, in this case, we're going to use name. So we expect this to print hello, Paul. Okay, let's see if that is going to be the case right here. You can simply do cargo run. And if all goes well, it actually printed hello, Paul right down here. So that is one way of formatting your string. The other way you can format your string is, or sort of whatever you want to print out is, let's do print line. Let's say you wanted you can utilize what you call positional formatting. So in positional formatting, you basically have a list of what you want sort of fixed within your string. Then you're basically capturing their values from whatever end you'd like. Then you'll simply bring it in within your string. So in this case, we could say, let's say someone or a name loves something. Yeah, something like that. So in this case, you're going to use still the name we provided right there. Then you can as well provide the values direct within this. So there's no harm with that. So let's try and do a color, in this case, blue. Just provide that within that. Now you realize that all my statements are ending in a semicolon. So please note that. It's very critical. Otherwise, you're going to face some more with the Rust compiler. So in this case, we have Paul loves color blue. And what if I had, what if I wanted to sort of, you know, change or rather interchange the positional arguments? So in this case, I wanted to say blue loves color Paul. Okay, that statement doesn't make sense, but just to bring out my concept, okay? What I wanted to show us. So in this case, you can use the positional the index of these arguments within your string, then you should be able to pull their values and put them at the right position within your string. So in this case, I could do 1. So in this case, index 1, which is going to refer to blue, then 0, which is going to refer to the value of this variable. So in this case, we should expect to see blue loves color Paul, something like that. Awesome. So that is exactly what happened. So we just reverted that statement. Yeah. The other way you could do that, still the same thing, is you may have named arguments as well. So in this case, instead of using indexes to do that, to accomplish that, you could basically use, you could provide names to these particular parameters. So in this case, we could say someone prefers something over something. Then right here, we could say there's a name, and this name is going to take the value from the name variable. Then you're going to say, we can say this is a house, bungalow. Sorry, these should be a string. They should be strings. Then we can have a car, right? In this case, we call the car Toyota. So right here, I can simply provide in the name, prefers, I can call this a car, and say a house, instead of providing the positional, the indexes within our statement. So if I went ahead and ran this in my terminal, let's see what that brings out. So we have these, the very last statement, George prefers Toyota over bungalow. So it basically used these positional arguments, the names we provided to them, to sort of achieve this. Okay, so there's a lot you could do with the print statement, but that is just a preview of what you can do. Now, the last one you're going to look at is what if you wanted to, for the sake of debugging, okay, for the sake of debugging your code, you wanted to sort of output, be it an array, a tuple, a string, an integer within your string without raising any error. We're going to, first of all, I'm going to write a statement that I expect to raise an error. So in this case, I'm going to simply print something, and I'm going to provide what I'm going to print right here. In this case, it's going to be a tuple of numbers or integers. Okay. Okay, this doesn't implement, so let me do that. So in this case, I'm printing a tuple of, so it's already, okay, it's already raising an error that I can't print a tuple in my terminal as a string, okay? So to resolve this error, because there's already an error even before I proceed. So even if I go ahead and run this, let's just try this out. So even if I go ahead and run this, there's already an error that is going to be generated, cannot be formatted with the default formatter. Why? Because a tuple has no, there's an error that was raised here. It doesn't implement the display sort of trait. So right here, we need to find a way we can be able to sort of display our tuple within our terminal or as a string. And the only way to do that, I think it should be suggested to us somewhere. It should be right here. So in format strings, you may be able to use this particular, you can be able to display our tuple using this particular, how do you call this? a colon, then followed by a question mark. So that is basically going to indicate that we expect anything, right, to be provided to us to print. So in this case, it's going to format it. So if I just clear this out and I rerun that, you realize that there's a tuple printed within our terminal, and that for us to be able to do that, you need to have that in place for you to be able to do that. So that is basically it about printing. That is basically or purely for debugging as developers, because you're going to run into issues within your program. Now, other than that, I want us to look at variables. So we can just call this variables.rs. Okay. I really hope everything is clear. Maybe if there's a question. Yeah. Named arguments. Okay. You could be able to define them somewhere else. Let me see who this is. Destiny. You could be able to define them somewhere else, just like we did over here, and then bring them in within your statement. So like the name, okay? Sorry, right here. So this name was defined in line 2, but then we just brought its value inside here. You could as well bring it in from somewhere else. Let's see if this is going to work. So let's say we had this defined within our main function, okay? Then you wanted to pass these within the show function in our print.rs file. Then right here, we basically are going to accept a name of type string. Sorry, this should be of type string. I hope that is going to work. Yeah, so we have this and we expect to use it within our statement right here. So let's see what this is going to generate. Awesome, you realize it all worked. Okay, so all our statements are generated as they were before. So I really hope that's clear, Destiny. If not, maybe you can just put it in the chat. We can we'll head back to that. Okay. Thank you, Samson. Thanks for the tip. So at this point, let me first try that and see if it's going to work. Oh yeah, Samson, you're okay. Okay, it's Control L. So we're going to look at variables. I'll just paste something there for to give us some heads up on this. Okay. So right there. Now, variables hold primitive data or reference to data, okay? And they are immutable by default. So we're going to see how variables are going to be declared in Rust and why they are immutable by default, or how we can deal with them, or we can mute them, sorry, within our program. So I'm just going to create another function right here. I'm going to call it vars. Then I'm simply going to import this within our main function, variables. Then I'm going to comment that out and do variables vars function. Now, heading back to our variables file. Now, there are two ways you can declare a variable in Rust. Now, one, you can declare it. Let's use what we had in the previous in our print function. So in this case, you are having a name and we are giving it the value George. I really hope, George, you don't mind. I'm going to use your name for the good part of this session. So in this case, I just defined a variable and I gave it a value George, but then I've not used the value yet. So that's why you can see the squiggle, the orange or yellow squiggle below the name. So if you do your variables in this format, then during the compilation of this particular source code file, Rust is going to explicitly give it a type based on the value you've assigned it and how you've used that particular value within your source code. Okay. So in this case, the value is a string. So it by default is going to give it a string type. So in this case, something like that. Okay. Then if we were to print this out, then that is basically what we do, and that would run. That would be that. Yeah, that was successful. You can ignore the warnings for now. We're going to, that is basically coming from the main function because I'm not using this, so maybe I can take that out for now. Now, if I wanted to sort of mute, right? So change the value assigned to this variable as it is right now, it would generate an error. If I try this, something like that, you realize there's an error right there, right? So in order to fix this, we need, because by default, variables are immutable in Rust. Now, if I wanted to mute them, then I'll need to provide, there's this keyword provided in Rust. And in this case, just allow me define another variable to sort of illustrate this. So let's say we had value age. So in this case, you're going to do 87. So, but then I wanted this age to be mutable because at that point, if I tried that, you realize that would generate an error. But then if I wanted to mute it, then I would do, sorry, should come before that. I would do let mute age. So in this case, you are initializing or declaring a variable, but then you're saying that this variable should be mutable, okay? And by providing this keyword mute, then we'll be able to now sort of change the value of that particular variable within our program. And that's why the error went away. Now, if I just came here and said, I'm going to print age, let's do away with that for now to avoid some warnings. So that should print 67. So first of all, during the initialization, it was given 87 as a value, but then in line 8, that value was changed to 67, and that's why we are ending up with 67 as a value from what we print out. So that is basically, if you wanted to define a value, a variable that is going to change its value at any particular point within your program, then ensure you use this particular keyword, mute, okay? Now, what if I wanted to define, sorry guys, what if I wanted to define a constant within my, I wanted to define a variable that is going to be constant. So it's going to hold a constant value all through the execution of my program. How can we achieve that? Now to do that, there's this keyword const that you can use. Then just for convention, you can follow or you can give the name of the variable in caps. So we can call these IDs never change. So we can call this ID and basically give it a value that you like. So we can just give it some random value right there. So this is going to be type, sorry. This is going to be a string. So str. Now, if I wanted to print the value of this particular constant variable, in this case ID, I'd simply come here and provide that name ID as a parameter. Then right here, all I need to do is compile that, and we'll have the value printed. So that is basically how we define constants within Rust. Now, if you're coming from a JavaScript background, you realize that this keyword, you sort of are familiar with them, the let and the const keyword. Okay, so const, you use const keyword to declare constant variables, and let for values that are likely to change their, for variables that are likely to change their values. Though in Rust, by default, variables don't change values. So you really need to note that, because you may face some challenges within your code, and I'm sort of giving you some heads up on how you should be able to debug your source codes. So, okay, mutable, unchangeable. Yeah, that's true. Yeah, it cannot be changed. So thank you guys for contributing in the chat. Yeah, Sharon, we're going to push all this code to a GitHub repository that I'm going to share the link with you in the group. So you don't have to worry about that. Time is really running, guys. Just allow me cover these. I'm really trying to push this so that we cover the most out of this particular session. So at this point, we're going to talk about types. I really hope, guys, you've got something to do with printing values and variables. So at this point, allow me talk more about types in Rust. So I'm just going to call these, let me adopt just one function name to make this quick. Okay, so I'm going to talk about types. Now in types, or types in Rust, you can, if you're coming from a background of some strongly typed languages, the likes of Java, C, C++, I think you must have been familiar with this. So I'll just give us a list of some of the types that are available to us in Rust. So that is the list. So here are some of the primitive types, the U8. Now, any type that begins with the U is an unsigned number. Okay, so in this case, it doesn't, at any point in time within your program, it is not going to hold any negative value. So U8 is basically an unsigned integer that is going to hold 8 bits of a number. Okay, so if your number is going to overflow, then it's your number is bigger than the 8 bits located, and there are going to be some error. You're going to experience some error. So we have 8, 16, 32, 64, and 128 or 128, all with their unsigned counterparts and signed counterparts. In this case, the signed counterparts begin with the I. Now we also have floats. So we have floats with the 32 bits and floats with 64 bits. So all these are numbers. All these basically define types of numbers that your program can hold. Then from there, we have Boolean types with the keyword bool. Then we have characters, chars. Then we have tuples and arrays, just like in Python. Those of us who are coming from a Python background, this is really going to make sense to us. Now, for now, we're just going to talk about the the primitive ones. That is the integers, the floats, the Boolean, the characters, the tuples and the arrays will be covered in our following sessions. So for now, let's deal with these. So I'm going to define still an age, and I'm going to give it, now I'm going to explicitly give it a type. In this case, it's going to hold. Now an age cannot be negative, right? So let's give it U8, data type of U. Let's use U32. Now, maybe something to just bring to our attention before I proceed. If I went ahead and did this, then by default, this particular variable has a data type of I32, okay? So that is the default data type of numbers in Rust. But then if you wanted to be explicit, then you can simply change that and give it an explicit data type. So in this case, I've given it an unsigned integer, and I've given the value of 65. Then so that is basically how you do that. So this is going to hold a value that can be represented with 32 bits. So if you converted that in binary, and it should hold 32 bits. Your number should hold about 32 bits. If it overflows, then it is going to interfere with the execution of your program. So you really need to take keen note of that and how you sort of bring some boundaries so that that is not, it doesn't overflow or go below. So that is basically how we declare that. So if I were to declare a float, so in this case, we can do, let me call this money. Money is usually in float. And I'll give it an explicit data type of F64. Then in this case, we're going to do, this guy has some 2000s worth of dollars, 0.50, okay? Yeah, so that works well. But if I were to change this to another type, so in this case, U64, and you try to execute, it should raise an error, okay? So anything with decimals, please use the float data types to hold their values. In that case, you will be explicit enough to define that. I'm not actually printing these values because we've printed them before. Maybe I can just print for the float and see what's happening under the hood. For now, I call that money. So maybe you can just do that. And okay, guys, we never brought this in. So let's import this in first. Then after that, we're going to simply run it. Awesome. So if I run that, you realize that the value printed is 2000.5. So it's basically printing a float, okay? Now, moving forward, let's talk about characters. Now, character is going to hold one character as it is. So if you're going to define, let's say we have, okay, what should we call this? I don't know if you can just give it the name character. So character is enclosed in single quotes, okay, as opposed to a string. You realize that a string, we were putting a string in between double quotes, but in this case, a character, you bring it just within a single quotes. So that should be able to print character U. Let's try that out. Okay. Yeah, so that printed the character. Now we could as well print what we call Unicode characters. So in this case, an emoji with a Unicode character. In this case, it could take something like I don't know if I'm going to get this right. I don't know if anything like this exists. Sorry. Okay. Oh, that is not how we write it, guys. This line should, yeah, should be something like that. Then these, yeah. So let's try and run this and see what happens. Okay, I don't know what kind of emojis. They should be something smiley, right? Smiley face, if I'm not wrong. So we basically printed an emoji with a is that yeah, it should be a Unicode character, and that is how you represent that. Now, if you were to put these in double quotes, then I'm quite sure it would raise it would raise an error. But that is basically how you do that. Now, tuples and arrays, you're going to look at those in our following sessions. So I'll not talk about that right now. Yeah, data types, I mean, unsigned means positive only. So you don't, the value, okay, we don't expect that value to have a negative, sorry, that variable to have a negative value at any point within your program. So if it is going to be unsigned, there are no negatives. We only deal with positives. If it is going to be signed, in that case, we can have a negative value or a positive value. Okay. So I really hope that is clear, George. Yeah. So that is basically how we do the. Thank you. That is basically how we do all the types, the data types you have in Rust. Now you basically can read more on that. Oh no, sorry. Okay. You can read more on that on the resource I'll be sharing with us by the end of this particular training. Now, the other thing I want us to cover, I'm really sorry, guys, time is already up, but let me just cover this before we call it a meeting. Let's cover conditionals. So in this case, we're just going to do if function, sorry, if statement, and then we'll proceed with the iterative structures later. So I'll just call these. So I'll just bring this in our main.rs file as a module, in this case, conditionals. Then I'll comment this out and do run. Okay, so in this case, we're basically going to learn about conditional structures. So in this case, if you wanted to execute a block of statement, but based on some conditions, okay? So let's say we had an age value right here, and this age is 3. But then we wanted to show a particular string based on the age or the value of the age. So in this case, you're going to do an if statement for us to achieve that. Now, this is how we do, or rather we write if statements in Rust. So we're going to say if age is greater than 18, then print this particular content. You can say your age, something like that. Else, if that condition was not met, in this case, it executed and the conditions were never met, okay? So you print these other statement, you are under age. You're under age, something like that. Now, if we go ahead and print this particular file or run it, in this case, the age was 3. So 3 is definitely less than 18. So our else statement of this, the else block was executed. However, if this age was greater than that particular, that particular value 18, then we have UR of age printed out. So in this case, line 6 in our if statement printed out. Now, that is basically how we do a basic if statement. What if we have or wanted to we sort of wanted to make it complex. So we had other conditions to bring here. So instead of just checking for one condition, age greater than 18, we wanted to also check if, and in this case, I'm going to use the ampersand operator to indicate and. So we're basically using the Boolean value on this end and comparing it to the whatever is going to be generated on this other end. So in this case, we could say, what could we put right here? Let's say course, right? And CS or computer science. So in this case, you're checking if your age is greater than 18 and your course is equal to CS, in this case, computer science. So if that is the case, to take up the course, else you're underage. So let's go ahead and see if this is going to run. Awesome. So our condition was met. In this case, the course had a value of CS, and the if condition or the if block was executed. But if any of these values were wrong, so in this case, let me say header CSA, something like that right there. Then I tried running, then you would have your underage printed because in this case, the condition is not met. Now, I really hope you guys understand what an AND statement or the AND operator does. So comparing the Boolean values from this side and this side. Now you can as well use an OR operator. In this case, that is how we represent it. This is actually similar with other languages. If you're coming from PHP, Java, I think, C, yeah, you should be familiar with this. So you can do all that operations right there. Now, if you had any other condition you wanted to test, other than the one condition we have right there, you could just test it as well, or put it as another if block and do your check right here. And if the condition was met, you execute that particular block of statement. Otherwise, you proceed to the else block. Okay, so we can have something like that over there. So in this case, if we went ahead and executed this particular file, okay, I wanted the line 9 statement to be executed, so I'm just forcing up the condition to do that. So here we have your underage, blah blah blah. So that means this particular condition right there was passed, and so the block of statement was executed. So that is basically, in a nutshell, how you'd really go about that. Now, as we conclude, I want to talk about a concept that is quite similar with what is in other languages, the switch statement in other languages. Now, if you're coming from JavaScript, C, C++, or the like, you should be familiar with the switch statement. Now, how do we implement a switch statement in Rust? This is how we go about that. So I'm just going to use the statements we have above right here in our statement, but then the keyword we're going to use is match. So in this case, I'm going to match age. Then I'm going to check if age is if in this case age is okay. If age is 18, then I'm going to execute a block of code, right? If age is 3, I'm going to execute another block of code. Now, in this case, I can just print, let me just copy these guys for the sake of time. So I just brought that in. Then if you're 3, I'm going to use this particular statement right here. So I'm basically going to do that. Now, use that there. So you have age. I'm going to use. I don't know why this error is. I don't know why we are having this error. Oh God. Okay. I think it was just a compiler thing completely. So here we can just write none. Okay, for now. Now, in this case, I have a switch statement, or in this case, a match statement in Rust, but it's similar to the switch statements in other programming languages. So I'm matching an age to these values, 18, 3, and you realize the last one, I have an underscore. So underscore is what we call default case in switch statements in other programming languages. So if you're coming from JavaScript, you would have switch, then you give it whatever you variable or value you want to switch. Then you'd go case this, case that, then somewhere within your statement, you feature a default. So if all the cases you provided none has been met, then the default case is going to be executed. Now, the default statement in Rust within a match statement is what we refer to as the underscore. So the underscore is going to handle any other thing that is not going to match. These cases are just given right here. So let's see how this executes. Okay, so apparently our value was 23, and 23 never matched any of our values. So line 23 was definitely executed. What if we had our value as 18? Let's just see what that is going to evaluate to. Awesome. So this is the statement that was given out. You are of age, take up the course. So right here, you are of age, take up the course. So that is basically how you do a match statement, okay, in Rust, or a switch statement in Rust if you're coming from the other languages. Okay, so that is basically it. I'm really sorry, guys, I've taken so much of your time. How do you have access to the videos? Okay, the recordings are going to be available. We're going to upload them on YouTube, but I'll be sharing the link in the Telegram group. So we should be able to get that in due time. Okay, Destiny, you never got some things. I hope you're going to go through the videos then in due time. In case you have any concern, that is, you can just raise it in our classes, in the coming classes you're going to have. Okay. So basically, that is how we go about some primitives of the language, defining a variable, printing values, defining data types, and a bit of conditionals. That is the if condition and the match statement, if statement and match statement in that case. So in a session tomorrow, we'll be looking at the loop statements and the tuples and the arrays data structure. Then I'll really brush first on how some concepts on OOP, object-oriented programming in Rust, because I want us to do tests on Monday, how to write a test or a unit test in Rust. And from there, we now start off the blockchain concepts early enough. So guys, is there any question? If you have any question, you can just shoot up your hand. Any concern? Yeah, I'll share the recorded link. We have, after uploading, that is, we're going to share all the links. I'm also going to push the work we've had tonight in a GitHub repo. That is the project in a GitHub repo. Then maybe you can follow with the code. Now there's some comments I've put. I hope you'll really be able to get around that and figure out what's happening. Okay. There's some parts I've commented out, but I really hope you guys will be able to figure that out. So if there's no question, I'll just welcome Cynthia. Okay, there's a question. Destiny?
Okay, sir. Can you hear me, sir?
Yeah, I can get you.
Okay. I wanted to shift the question before, but it's okay. Let me just ask and reduce the one of the future because the network is actually disturbing me. I got out of the meeting several times and came in several times, so I did not get everywhere right. But anyway, I have two questions. One is this mod in the top of the file. Is that an importation from a library? The mod print, mod variable, mod types, mod conditioner, are you importing from a library?
No, I'm importing from a module. Now in Rust, now if you're going to, and I think I'm going to share this with us just before I finish, there's a way the keyword mod is used to define a module in Rust, okay? So a module can take the keyword module, then you can give it a name, any name you can think of. And yeah, that is basically the structure it takes. Now, but then we're not going to look at this, so you can just find your time and go through that. There are a lot of things you guys can learn in Rust. Now, I was saying, if you have other Rust files within your project, but then you wanted to sort of link to them or import some functionalities from them, the way you do that, because since this is within your project, okay, it's local within your project, you're not pulling anything as a dependency. So you just bring them in as a module within your main.rs file. So these are modules within your project. However, if you are to pull an external library or a dependency in your project, there's another keyword you would use, and that is use. We're going to see how to use this as we begin the blockchain bit of our training, how we pull external libraries or external dependencies into our project.
Okay, I want to ask another one. What's the purpose of bringing them into this main.rs?
Well, the purpose of bringing them in is so that the compiler, because as we said, the main function is the entry function to our program, okay? So while we compile our project, the compiler is going to look for a main function within our main.rs file. Now, if it won't find that, then it won't compile our project. In other words, it won't, the compilation won't be successful. I can just maybe demonstrate that. Let's say I changed that function and you realize there's already an error within our main.rs file. So it's not detecting a main function. And that is also indicated right here. Main function not found within the crate. Now, our main.rs file, like I said, is our entry file. So it's the entry to this particular project you're working on. Now, if there's no main function within our main file, in this case, main.rs, then that file is by default going to occur. So the main function is very critical for us to execute other functions within it. Yes?
Okay, so without the main.rs, we can't compile every other module. We can't compile them on their own.
or without the main function, right?
Yeah,
Yes.
I'm talking about the main.rs file. Without that one, we can't compile the rest module. Is that okay? Okay.
Yeah.
So another one, I
Okay.
saw you using cargo. Cargo word just now. I noticed it's like you are using it to compile.
Yeah.
Cargo. Well, is it just cargo you use or what?
Okay.
In the terminal.
If you install Rust, within your machine, and all, it will by default install cargo. Now, like I said, cargo is basically it's like a package manager for Rust, just like you'd have npm for Node. So if you wanted to pull any dependency, you just do npm install something dependency, right? Now,
yeah,
Rust, yes.
I don't want to stress you. I don't want to say far. I saw it, but I read through the documentation while in installation. I even did the practical. I used cargo on my terminal to write a code. Info created a fresh file. The same way we use mkdir to create the file, just as what you did. But I saw you compile on the terminal. That's why I'm asking of it. Okay, my last question is that of the match. Can you hear me, sir?
Yeah, I can get you.
Okay, that of the match. I noticed something about the match. In the first one you did before coming to the match, that one is like okay, that of the function which you use if, else if, then else. It's in range, which means it don't have to be exactly that number. It's in between 3 and 18, above 18 and below 3. But in March, 18 is 18, 3 is 3. That's another thing I noticed. Am I right with that understanding?
Yeah, that's true. So in this case, we were in the if statement, that is, we were trying to, it was based on the Boolean value. So it's the Boolean value generated after executing the conditional expression, right? Now, when it comes to the match, our cases were basically values. So we already have predefined values. So what if we wanted to sort of go with still wanted to stick with our conditional values? How would you go about this? I don't know if this can work right here, but then, okay, sorry. This is how I think we go about that. So we could simply say, if age is okay, this doesn't seem to work here. But allow me research on that. But this is basically how you do it with the other languages. Let me see how that can be done in Rust. Then maybe I'll just present that in a class, in a session tomorrow. Okay. Hello, Destiny. Destiny, are you there? Okay, maybe we lost him. Yeah, I think we lost Destiny. So I'll be tackling that particular issue in our session tomorrow before we proceed with the loops statements. So is there any other question from anyone?